Imagine for a moment we, as a species, decided to build a star, not in the distant cosmos but right here on our home planet. This isn't science fiction. In the south of France, a monumental project is underway, a testament to human collaboration and our boundless curiosity. Scientists and engineers from around the world are constructing a machine called ITER, the International Thermonuclear Experimental Reactor. It stands as one of the most ambitious scientific quests humanity has ever embarked upon. We are not just looking up at the stars anymore, we are actively trying to recreate their incredible power source for ourselves. The goal behind this colossal effort is both simple and profoundly important, because it could unlock a new era for civilization, providing a solution to some of the greatest problems we face today. This is our generation's cathedral moment, a project that will define our legacy. For centuries, our progress has been fueled by burning things, but it's a gamble we must take for the sake of future generations. Welcome to Scratch to Fortunes, where billion-dollar ideas and groundbreaking inventions come to life. If the future of fortune excites you, hit subscribe. So what exactly is this stellar fire that we are trying to control? It's called nuclear fusion. To understand it, just look up at our sun. The sun is a gigantic churning ball of gas, mostly hydrogen. At its core, the force of gravity is so immense that it squeezes hydrogen atoms together with incredible pressure. They become so hot and so compressed, they overcome their natural repulsion and fuse together. In that process, they form a new, slightly heavier element, helium. It's a moment of cosmic creation happening countless times every second. When those hydrogen atoms fuse into helium, a tiny, tiny fraction of their mass seems to disappear. This is explained by Albert Einstein's famous equation, E equals mc squared. That energy, born from fusion at the sun's core, then travels 93 million miles through space. It warms our world, drives our weather, nourishes our plants and powers all life on Earth. Every ray of sunshine you feel on your face is the product of nuclear fusion. The goal of projects like ITER is to replicate this exact process, but on a much smaller scale right here on Earth. We want to build a machine that can take hydrogen, our fuel. Why go to all this trouble to build a star in a box? The answer lies in the incredible promise fusion holds for the future of our planet. For too long we have relied on burning fossil fuels, a process that releases vast amounts of carbon dioxide and other greenhouse gases into our atmosphere. This has led to climate change, air pollution, and environmental degradation. We have been living on borrowed time, consuming finite resources that pollute our planet. The fuel for a fusion reactor is derived from simple and incredibly abundant materials. One ingredient is deuterium from seawater. The other, tritium, can be produced inside the reactor itself. This means the fuel supply for fusion is virtually inexhaustible, enough to power humanity for millennia. Furthermore, fusion is inherently safer than fission, no runaway chain reaction. Fission creates long-lived radioactive waste that must be stored for thousands of years. Fusion combines light atoms and produces helium, the same harmless gas in party balloons. Reactor materials can be chosen to keep activation short-lived and manageable. If anything goes wrong, the plasma cools and the reaction stops. No meltdown. Fusion offers the benefits of nuclear energy without the long-term risks and waste. So how do you actually build a machine capable of containing the heat of a star? Well, the heart of the ITER project is a device called a tokamak. It's a toroidal chamber, with massive magnetic coils. Inside it's a vacuum chamber, the container where fusion takes place. Scientists inject a very small amount of hydrogen gas. Hydrogen, the fuel for our artificial sun. Next, they heat that gas to almost beyond comprehension, 150 million degrees Celsius. At that temperature, hydrogen becomes plasma, a turbulent cloud of charged particles. Plasma is electrified and cannot be allowed to touch the walls. No material can withstand that heat. The plasma would vaporize the container. The solution? A magnetic cage. Colossal superconducting magnets that wrap the donut. Those magnets are cooled to nearly absolute zero. Hottest temperatures next to some of the coldest. An extraordinary thermal contrast. The magnetic field traps the superheated plasma, suspending it in the middle of the vacuum chamber. The plasma races around the donut, contained by forces we cannot see, waiting to ignite. It's a cosmic ballet of extreme heat and extreme cold, all happening just meters apart. The path to achieving controlled nuclear fusion is paved with immense scientific and engineering challenges. Maintaining a stable plasma at 150 million degrees is one of the hardest problems humanity has ever tried to solve. The plasma is naturally turbulent and unruly like a wild storm trapped in a magnetic bottle. Scientists are still perfecting magnetic confinement, learning to tame wild instabilities. Every step forward is a hard-won victory. The ultimate goal for ITER is a burning plasma, a state where fusion sustains itself. Target: produce 500 megawatts of thermal power from an input of only 50 megawatts, a 10-fold return. While ITER will not feed the grid, it will prove the concept at large scale. If we succeed, the benefits will be transformative. Think of a world free from the environmental burdens of our past. A civilization powered by the same clean, sustainable energy that illuminates the cosmos. It could illuminate cities, power homes, fuel space exploration, and provide clean water through desalination. The ITER project is more than an experiment. It is a profound symbol of hope and unity. In an era of division, this global collaboration shows what we can achieve when we work together. The journey is long and success is not guaranteed, but we are the generation that began building a star on Earth. Your support means everything. Leave a comment, like, and subscribe to Scratch to Fortunes for more inspiring stories of world-changing inventions and the people who turned them into fortune.